Welcome to Chip Logic Studio, and in this video we will discuss about UVM Testbench, as our poll decided that we will take UVM Testbench. Before starting the video, watch my previous video about architecture, because architecture is most important for writing any kind of testbench. And writing testbench, I will tell you some tips that whenever you start any testbench, just write whatever is inside our architecture. So our architecture has our module top. Okay, so write module top and module. Nothing to care about writing inside the module. Second thing is our test. So write class test, and in UVM we will extend this, and this is because everything inside UVM is in a hierarchy, and that hierarchy means there are previous methods written in our hierarchy, like UVM test is there, and in that UVM test every method is declared already. So we will use that similar method in our classes or our parent class methods in our child class. So every class will be here child class, and we will use that method. So this is called UVM. This is only the UVM. There is hierarchy already declared method, and we are using that method for making ease of verification. That's all. That is the proper definition of our UVM. Now, like class test is there, class environment is there, similar extend. Rest of the thing is our similar to our ASIC test. Class test, UVM test, environment. Okay, everything will be like this. Everything will be extends from our previous class. So, and the tip is that if you don't know anything, just declare one file. Like here I have already declared some files. You can see like sequence, transaction, agent. Declare files .sv. You know that much, that you can write a router layer. So at least you will start to write your test bench. Whatever inside now, we will go to that. So first is our test bench, which is our TB top. So what is TB top? TB top is the top layer. Inside that we have our three things. That is means our interface. Second is our module, which we are taking as a multiplexer module, and third is our package. Package has all the classes inside that. Let's see the package only. So this is a package, and package is a simple syntax which has a hierarchy of files which are inside our package. That is, you can learn this by bottom to top approach. Like test will build first because it is a component, then environment, then agent, then sequencer, then driver. Then if monitor is there, monitor, scoreboard is there, scoreboard. Then at last we will declare our object. So object versus our component video is also there in interview section of my channel, so you can watch that video. Now you have to declare this UVM macros.svh, because everything like small syntaxes or all the methods are declared in that, so you have to import that package. So this is a simple thing you have to include. So this package we have included in our UVM top. So what are inside our top module? As my architecture video, our interface, our module, and our package. Okay, package, and then we will see what is our multiplexer module. A simple Verilog code of multiplexer. Output, input AB, our select line. Logic is our data type for all of the thing, because it works as a wire as well as it works as a reg. Third thing is our assign statement we have used. So y equal to select. If 1 is there, then A. If 0 is there, then B. Simple. This is our simple module for our multiplexer. Now include our module. So our multiplexer module is instantiation, that is mux m y a b and our select. Our import is necessary, so we can use all of the things inside our packages. So multiplexer is combinational block, so we are taking our global clock for synchronization between our test bench. Okay. Second is our interface, which we have included after our DOT, that is interface, and we will send this clock to our interface, because both module and interface and our test bench should know that there is a clock which is synchronized our module, interface, and our DOT. Now this is our config DB, a very important thing. In our ASIC testbench we are using configuration class, or we are sending with the new constructor every time our virtual interface. So in this UVM we have a special thing, our UVM config DB, which has a ability to store our instantiations, or you can say our handles. So virtual handles will be stored in that UVM config DB. I have already made this video, so you can watch that video. So virtual interface we are taking, and simple syntax is there: set null, and star means all throughout the environment we will get this virtual interface, and keyword is our VIF. For that, using that, and int h is our handle. So as our declared handle is our int h. Okay, simple thing. Now run test is our method. Inside our top module, you must write the run test method, which will run our task inside our test class, which we will see after this class. This is used for only in our EDA playground for our waveforms, so skip this. And our simple clock generation for 5 nanosecond, our T on or duty cycle 50%, and our clock generation method is our initial block. Simple. Now we will go over test class. Now here our UVM main things are started. So there are 9 phases in UVM. You should study that. Also made a short for that. 9 phases of UVM are there. So we are using here first 3 methods. So as I said earlier, we will extend this from our hierarchy from our UVM. Then this is our micro, and macro doesn't need any semicolon. It register our class in our factory. So that hierarchy or declared method in that hierarchy is called factory, and in that factory we are registering our test class, so our test class can get every method inside our UVM test. So our component is the thing which is throughout our environment, which didn't get destroyed, and object and component, that difference is must, because we need something to get created every time and stored every time, and some things which should stay throughout our simulation. So component are those things, and this component tick UVM component utilizes such a micro we will use every time when we will register our every class, or every every component is our class, environment, driver, monitor, which will be throughout our simulation. We will register with this micro. And as our hierarchy is going on, our sequence and environment is there, because sequence is our object, so we can declare anywhere, and our environment class is after this class, so we will take this handle and we will create this handle. So there are special syntax for that. So environment handle, which is that environment, it is inside our environment, means environment env, this thing which I have highlighted is our main name of our class, and which is type id, means every handle has its own type id, and we will create this with the help of environment handle. And this keyword is used here, means that this handle environment, this which I have highlighted now, this handle is our new handle for this class. This is our new handle used in this class, so this method is used there. So create method will register this and also call a new constructor in our next class, which is environment class, so it will build after this. So these two things is done by our create method. And as our phase is there, our build phase, we will build this environment, and I skip this because I want to tell something new about this. New constructor has our string name test, means the name of this class is our test, and UVM component parent is not, means before this class there is nothing as a parent, means in this environment there is nothing, but previously we have UVM test which we have extend, and string name is our test, means this class name is test, and this thing we will pass to our UVM test class in hierarchy that we have registered such things. And as our have a connect phase and super keyword also have created one videos you can watch. And last our run phase. And run phase we will create this object here. Then this is new thing, that is phase dot raise objection, and this means this raise objection in this class which is created, which is called through our top module. We have created our sequence handle, and this handle will therefore until the drop objection is called, and when the drop objection will called is after it will call internally after this whole process is completed, means our simulation is completed, then our drop objection is called. So this is must sequence, and you can write number of raise objection and drop objection or number of times you need it. but mostly we use one time only because we create different sequence and test for different scenarios. Now, sequence.start environment.agent.sequencer means this sequence we are running on our sequencer, and this sequencer has part in what it is inside our environment, and environment has agent, and agent has our sequencer. So this hierarchy is followed. So sequence we will start on sequencer, as our UVM suggested that this sequence will start on sequencer. So this syntax you should know that simple creation of one sequence, then raising one objection that we will raise, we will start our simulation then, and then after this delay is used because there should be one time that 10 nanosecond or something before drop objection. Okay, means our simulation is complete after some time is given. I give this time because I like to give time before the simulation. Now drop objection is there, so this is only a new thing. This will be written only on the test class and not any other class. So this thing is specific for test class, so you should remember. Second thing is our environment class. So simple thing, our extend from environment end, and as our agent class is inside our environment class, so we will declare agent and create our agent as our previous class. Similar for our new constructor and our connect phase and our end of this phase is new phase, end of evaluation we are using for printing our topology. Simple syntax is there, UVM top dot print topology, and you can print. You can use this inside connect module or connect phase or any phase, this syntax, but I have used end of evaluation phase, so tell you that there are different phases. So similar for our agent also, the syntax is same. Don't think UVM is any hard thing, it is just about hierarchy. It is just about hierarchy and some syntax, nothing more. Simple UVM component util, extend from agent and class, simple copy. You can copy paste these things like your new constructor, just you have to change that agent name and all the things, and you can just declare because agent has driver and sequencer, so you have created driver and sequencer, simple thing created. Now this thing is new in connect phase, like in our SE we connect differently than our UVM. In UVM already declared some ports inside our driver class and sequencer class, so that declared port that called the TLM ports. So because we don't use anything like mailbox in our UVM, we use TLM ports, and this because it is more flexible than our our mailbox, so there is name as sequence item port, which is inside our driver, and we will connect this with our sequencer, and sequencer has sequence item export. So there are some communication medium between them, like FIFO you have understood in mailbox. So we will understand this syntax one more time. A driver has our sequence item port, and connect with our sequencer has our sequence item export. So simple connection dot connect we have used for connecting these two things. So agent is also covered, and now finally we will go towards our sequencer, because sequencer will send this thing to our driver, and sequencer has the simplest syntax, and but only thing is that we have to parameterize with our transaction class. So first we will see transaction class. So transaction class has our transaction, it is similar to our packet class, but it is extends from our your sequence item. Now first time we will see our object utils, because transaction is our packet created as every build phase. In simulation number of times it will create, and I will show you how many number of times it will be created. Rand is our randomization variable for A, B and select and end class. So simple syntax, an object doesn't have any phases because it is object. It is created at runtime and destroyed at runtime. So an object are created from the zero simulation, so it they should have every phases for synchronization, but object doesn't care about that. So rewriting object is the simplest thing. Just write some new constructor and object utils a transaction and just declare some variables, and you can write constraint here in your transaction. And next thing our sequence, because sequence will send this transaction, as you see parameterized this transaction, and it is also an object. new constructor. This thing is new. Here is our task body, because you will say that you will create this request is also inbuilt inside our sequence, and this request is our transaction request we have created here. As you see, I haven't declared a handle here. I can declare, it is not compulsory that you should not declare. You can declare any other name, you can declare that is also fine, but a request is already there, a handle. So request a transaction type id, create one request, and here as you see there is no this, because we don't know that number of times the request will be there. So this will be no same, this will be not a same request as previous request, so there is no need for this keyword. And I have said that I will show you how many numbers of time it is created. It is 100 times it is created with the repeat loop. And here is a handshake between our sequence and run driver. I have created this video in our interview section, so you can see. And there is a method called start item, which will send our request to start this request. Then we will randomize this request, and then we will call finish item request when the response is coming from our driver. So as we were in our sequencer, so sequencer will have our component, which is parameterized with our transaction class. Simple syntax for any component is our, at least there should be a build phase, and at least there should be a parent handle or something. It is null. It is similar syntax with every component class. And we go to our driver after sequencer. So driver has our transaction as our parameterized with our transaction, and it is also a component. And here we have used our virtual interface, because we need to send our data to our interface, then our new constructor, and our build phase. So in this build phase, as we have written our syntax to set inside our top module, we will get this our virtual interface from our top module to our driver. So this will get simpler in our UVM. So therefore UVM config db is there, some storage elements are there. I think 100 entries you can do about handles in our UVM config db. And connect module connect phase is not needed here, but I have written, you should write in every component if you need to extend something. And finally our run phase, and in run phase, which has started from our top module, then you have seen in our test, then directly in our driver. So here our sequence item port to dot get next item, which we are sending with our transaction to sequence to our sequencer, and in driver we will get this get next item request. So request has our all the transactions, and as our syntax or our SV concept, simple concept is that interface will have this select from our request, then A, B and Y, all the values we will take from request created in transaction, sequence and sequencer to our driver. This request will go to our interface, so we will also go to our interface. And this sequence item then and should be written it is also the part of our UVM environment syntax, that is our sequence item port dot get next item and sequence item port dot item done. So these four things, like these two, and in our in sequence, so this start item and finish item, and our driver sequence item port and our sequence item import, sequence item port get next item and sequence item port item done. These four things are in method used for handshake between our sequencer and driver, and after that all our environment is our completed. So in this way there is our environment. So simple syntaxes are there and nothing complex in our UVM. Just we have to extend our class because it is hierarchy system, and in that some method are declared. So I will one time run this whole program and I will show you hierarchy as we have written our topology. So as I said earlier, the tip is simple. Just use this method to create every important and start creating environment. So as I said earlier, you can write every environment class, extend that class, register either component utils or object utils. Then some important terms are your raise objection, drop objection, and sequence and driver handling. These two things you should consider. Everything is fine other than that. And this is our final output. You can see the monitor is not there, so after interface you cannot see the output. in after interface you will get it with our monitor, then you can see the proper output. So for now output is 0 and our every other thing is working properly. Our clock signal is not there. I will give that signal. So this is our clock signal. So other than that all things are working, and as I promised I will show you hierarchy. So this is our hierarchy. As you can see, as I said earlier, the sequence atom port and sequencer has sequence atom export. It is already declared in your drive, and these methods are used internally because internal methods are also there in our UVM. So this all methods and all the things are already there, and you can use or internally it will use everything. So this is our hierarchy. Like top has environment has driver, agent has our driver, and with driver there is also our sequencer. So this simple treatment is there. You can add a monitor and coverage and everything you need in your environment. You want 2 driver, you can add 2 driver, anything is fine. Don't be limited with only a simple architecture. You can experiment with multiple things. So thank you and subscribe my channel.